Okay, this video is talking about exponent rule number 2, the quotient property. And so when we are working on this quotient property, remember quotient means division. The quotient is the answer to a division problem. So we're going to start it the same way that we did before. We had our first example here. We have 3x squared y divided by 6x y cubed. So step 1 is going to be just to break it down. So let's take our 3x squared y and we'll break it. And so we can't break 3 down. So we have x, and we have a y. And then we have divided by. Remember, a fraction is just a division problem that has not been worked out yet. So this would actually be considered an algebraic fraction because there are variables in it. So let's look at 6. 6 breaks into 2 and 3. So we'll write 2, 3, x, and then we have y, y, y. Step 2, it would be to cancel or to divide that common factor out. So I have a 3. 3 goes into 3 once. 3 goes into 3 once. I have an x. We're going to do a squiggle for the x so that it looks different. And I have one y. And then we're going to write what we have left. So we have x divided by, we have a 2, and then we have y, y, or x divided by 2y squared. So that's our first example. Let's take a look at our second example here. Our second example, we have 4p squared n squared divided by 8p to the 4th n to the 6th. So we're going to do the exact same thing, break it down. Well, 4 breaks into 2 and 2. So we'll write those there, 2 times 2. We have 2 p's, and we have 2 n's. And then our 8 breaks into 4 and 2, or 2, 2, and 2. So we've got 3 2's. We have 4 p's, and we have 6 n's. Alright, and so now we're going to cancel. 2 goes into 2 once, 2 goes into 2 once. Cross out our other 2's. We can cancel 1 p, 2 p's, and 2 n's. It has to be one in the numerator and 1 in the denominator. You cannot cancel everything out. It has to be 1 for 1. Now, I have this one, everything canceled out of the top, but remember when we canceled them or divided, 2 divided by 2 is 1. So we'll have a 1 left in the top when everything cancels out. And in the bottom we have 2 p squared, and then we have 4 n's, so we have n to the 4th. Okay, well let's look at one more example, and this time, just like the last one, we are going to put we're going to put one that's a little unreasonable that we don't really want to write all the way out, just so we can develop our rule. Well, the only reason we're developing the rule is because it is quicker, but a lot of times people forget it, and so breaking it down like this always works. So let's go with something that looks like this. We have negative 2, and we have x to the 400 divided by 3x to the 20. So if we think about how this guy would be written out, well, 2 doesn't break down to really anything. 3 doesn't break down to anything. So those aren't going to change. However, if I wrote 400 x's out, and I had 20 x's down here, those 20 x's will cancel with 20 x's in the numerator, and that's going to leave me with x to the 380th. So I would have 380 x's up there. So actually the rule is we have x to the n over x to the m. We're going to subtract those exponents And wherever you have the most is where it's going to go, if that makes any sense. So I had the most x's in the numerator. I had 400 of them up there, and I only had 20 in the denominator. So 400 minus 20 is 380, and most of them are up top, so I'm going to have leftovers up top. So this would be x to the n minus n. However, if I switch that and I had the 400 down here and the 20 up there, then my 380 would be below. So the one thing that always works, you can always write them all out, cancel, or divide out your common factors. That will never fail you. You can use the rule if you remember it and it is your favorite and you're effective with it. You're welcome to use the rule.